vegetation classification series. And it is organized by the Vegetation Classification Working Group of IAVS. So you can, if you are not a member, you can become one. You can see the QR code on the screen to see more updates, more seminars, lectures in the future. And also this seminar will be recorded and will be available on the our YouTube channel. So the seminar number 3 today will be about 45 minutes, and afterwards will be some questions around 10-15 minutes. So you can write the questions in the Q&A. So it is on the top panel. You can find Q&A and write your questions during the talk, or you will have a possibility to unmute yourself and ask questions at the end. Okay, and now I pass microphone to Scott, who will introduce our today's speaker.
Thank you, Dennis, and thanks to both Dennis and Aaron for putting this whole series together. It's been enjoyable, and I look forward to all the next ones. And I especially thank you for inviting Jozef to give a talk. Jozef's been a friend and colleague of mine for 15 years or so now. We met over a couple of meetings, but also our research overlapped a little bit at Rocky Mountain National Park when we were both there collecting some data one summer. Jozef received his PhD in 2007. His focus then was on phytosociology. He's been playing with that ever since, but broadened out quite a bit as well. He worked for Natura 2000 way back in the early 2000s, spent actually a few months down in South Africa as well at the University of Stellenbosch. And then he joined the Institute of Botany back in 2003 and has been an integral part of that institute ever since. His work spans actually throughout Eastern Europe, and indeed throughout the world. So you're going to hear a little bit more about what he's done in the Americas today. So I don't want to take too much of your time, Jozef, but thank you for being here and look forward to your talk.
Thank you, Scott. Thank you, Aaron. And thank you, Dennis, for this opportunity to share some information about vegetation classification in North America. It's strange that, oh, not so much strange, because I will speak that there was more Europeans doing research in the US. So I will start to share my screen. Can we, oops, cancel again. Okay. Can you see my screen?
Yes, can.
I got no answer. Okay. Thank you so much again. So good morning or good afternoon. It depends when you are. So I will be speaking about vegetation classification in alpine and Arctic areas of North America. And as I mentioned, I'm not the first or the only one Slovakian or Czechoslovakian guy coming do research, doing research in the US. There was more people, and I would like to mention these three people. Actually, Emil Hadač didn't work research in the US. However, he did a lot of research in the Arctic and in Iceland, but affected plant community classification also in the North America. But very important for North America was Věra Komárková and Vladimír Krajina. Věra did her research in Rocky Mountains and in Alaska, Vladimír Krajina in Canada, British Columbia in the Rockies. However, all these guys started their research in the Tatra Mountains, the highest mountain range.
Sorry for interruption. Somehow the screen is very blurred. Maybe you can stop it and try to share again.
Okay, so let's do it again. Is it better?
It's yes. Let's share it.
Yes, but let's go for slideshow.
Yeah. Yeah, it seems much better. Thank you.
Thank you so much. So, okay, so all these guys started their research in the Tatra Mountains, highest mountain range in Carpathian Mountains in the Europe. So they affected also thinking and looking at plant communities in North America. Here is the map of ecological regions of North America. You know it very well. And I will be focusing on this green and violet color, these northwestern forested mountains and tundra region. Komarkova, in her research in the end of 70s, actually in the year when I was born, did research in Rocky Mountains and then in Alaska. This light gray area means the regions that where this ecological or syntaxonomical research have been done. And we can see also distribution of alpine and Arctic tundra in North American continent. And I will be mainly talking about the Brown-Blanke approach. First, I got the picture of great guys that I've been lucky to meet, Skip Walker and David Cooper, but because of GDPR and I didn't ask them for permission to share the picture, so I changed it to more general picture of doing some kind of research. Here is a list of papers that were somehow based of syntaxonomical studies following Brown-Blanke approach in the US. It started in the 80s, and there were authors like already mentioned David Cooper, Skip Walker, Marin Walker, and then it continued also through various authors, but there is also more studies doing by Amy Breen or Anya Kade, focusing on various vegetation types. I would like to especially emphasize this paper of Dave Cooper in Brooks Range, because it was like first comprehensive list of syntaxa from Alaska region classified into meaningful system. And here is another study, more recent. Christian Dam in 2021 published his PhD thesis and did a really great job. Unfortunately, this work never been published. So it's a manuscript or PhD. So all syntaxa that being described in this work are mainly invalid, but you can have really good overview what have been done and by whom. So you can see many papers that were focusing on vegetation studies. Some of them have also broader perspective. But the very important papers being papers of Betty Willard and already mentioned Vera Komarkova Czech woman that was also professional climber and first woman in some Himalaya peaks. And story continues. So Skip Walker starting following European approach and mirroring European Vegetation Archive initiative that ended in creating or establishing Arctic Vegetation Archive. And here you can see number of relevas from whole Arctic biome, Circumpolar Arctic Vegetation Archive, containing couple of thousand relevas that are already in the digitalized, and we can use them for various purposes. However, there is some preliminary list of brown blanket syntaxa that we published, but it's just a beginning, because when you put this kind of information together, then you can see what are the differences, what everything is missing, and where we should go further. So this is just a beginning, and there is somehow idea to follow this approach that is done in Europe. First, that before I skip into the vegetation classification, I will mention some commonalities and differences between Arctic and Alpine. And when we are talking about classification of Arctic vegetation, we usually take into account also Alpine vegetation, because there is many similar features that we have to take into account. So these kind of vegetation are repeating in both environment. So when we look at Alpine environment, so we see that there are changes between day and night, in contrast to Arctic, when there is long summer and long winter. There are also differences between light availability, wind patterns, moisture level, and also biological activity. And I will be talking a little bit more about these differences, so we can see the differences between high latitude and high elevation. This is also mirroring in number of species. So while Arctic biome...
Sorry, Jozef, again, your screen is blurred completely.
Again,
maybe you exit and...
Okay, so this
I don't know what happens.
Maybe slow connection, I don't know. I will start it again. Share. Okay, and let's try again.
Oh, it's good, thank you, yes.
Okay, so just let me know again. So I started to talk that there are big differences between number of species occurring in Arctic and in Alpine. While in Arctic there is approximately 1,500 species, in Alpine ecosystem through the world, there is approximately 10,000 species, so it's much more diverse. When talking about species that are dominating the plant communities, we should know that in Arctic there is approximately 10 species that are very dominated in habitats, while in alpine areas the communities are more diverse, and there is more graminoid and forbs that are influenced by local micro and meso environmental conditions. Also, when we look at soil carbon accumulation, so we see that there is less disturbance in Arctic, so and there is higher soil carbon accumulation than in the Alpine. Regarding permafrost, while in Arctic, permafrost is widespread, in alpine tundra is patchy and mostly in higher ridges and in smaller areas. Also, there are big differences between weather during summer. There are differences between day and night during summer, while in Arctic tundra, the conditions during summer are more homogeneous. So here is the list of some features that are different in both environment, but finally we can see that many communities are repeating. However, there are differences in phytogeography and geological history that affected recent distribution of plant communities. And here we can see also landscape or topography differences or some variability. We can see that depends on slope and variability. We can have dry communities, some wet base of slopes, and this also affect all environmental conditions that are important for inhabiting by various plant communities. So I mentioned that the ideal situation for us is to have also something similar that is in Europe. This amazing FloraVeg web page that is summarizing wisdom or knowledge about plant communities and habitats in Europe is a good example where we can proceed and how this information can be utilized. So, and I started to speak about brown blanket approach, but this was long way. This FloraVeg web page synthesized more than 100 years of knowledge. And this was also utilized in EU legislation because there was a unit system based on brown blanket approach, somehow modified with meaningful crosswalk when it is possible, of course. But this is just an example how this kind of information can be useful even in legislation processes in some government purposes. And when talking about vegetation classification in the US, it has to be mentioned that there is widespread natural vegetation classification system that is different. We can look at them as top-down system based on physiognomy or growth forms, then taking into account also some biogeographic features, and then also some floristic. So there is hierarchical system consisting from classes, formations, division, macro groups, and also alliances as association that are used in brown blanket approach. Similar system based on brown blanket approach, developed or starting by Kraina in Canada, resulted in creating bioclimate units that are widely used in Canada. And also there is this amazing work of Don and Wolfgang that are trying to create this hierarchy for natural vegetation throughout the world using natural vegetation classification and these systems. They will be speaking about this approach later. However, another system, biome system, about large-scale ecosystem that comprising biotic community and its environment that is driven by energy, by temperature and humidity. And there are 4 spatial tiers distinguished like zonal biome, global biomes, continental biomes, and regional biomes. So another level of classification, and developed by Laco Mucina. These also take into account isonality, extrazonality, or intrazonality. It is also important factor. And Javier Lloydy was talking about a similar system, but different, just a few weeks ago. I think these are all very good initiatives that are very important because vegetation is a proxy for all things that are happened on the world. So we somehow have to classify these units into meaningful boxes. However, the main goal should be that there should be some meaningful crosswalk or overlapping, that we have to explain which language we are using. And of course, while there are many same terms, as I mentioned, within the hierarchies, like classes, alliances, associations, sometimes they are of different meaning. So they are not equivalent of in different classification system. And sometimes we are able to do this meaningful crosswalk, sometimes not, but it's okay, because we all are talking different languages, but we have to somehow communicate. And here is an example that sometimes we are not able to find that crosswalk. And what is important? According to our discussions, it's to know what are our goals. So we have to create some adaptive vegetation classification that is scale dependent. And this scale depends on research objectives. So we can have vegetation classification system for large spatial scales. We can use biome system, NVC system, or bioclimate classification. And we can have also small spatial scale that is using, for example, brown blanket or habitat approach. So it doesn't matter. So, and this is just an example. When we collecting plot, classifying these plots into some meaningful communities or syntaxon, and then we can go to higher levels that can be used, for example, when mapping vegetation through remote sensing techniques or various purposes. Brown blanket approach is good when we are looking on small scale gradients, how they are changing, how they are affecting changes in plant communities. And of course, the important thing is that this system must be somehow standardized. They can allow us to be automated. So automation must be a need. They must be repeatable. That is very good system for brown blanket approach based on floristic criteria. Or we can use biome concept based on climate data or physiognomy. And also what is important from my point of view is common language, like nomenclature, because sometimes where I'm traveling and working with different classification systems, the names are just names, and sometimes I don't understand. But when I am using like nomenclature systems that is coming from brown blanket approach with certain rules, so usually I can see beyond each name certain floristic combination. I can see also environmental conditions that are affecting these floristic combinations, and this is helpful for me. And of course, system must be consistent. So when we have certain hierarchical level, we should consider, for example, climate. Then we should consider, for example, other factor like soil or humidity, and so on and so on. And this should be applied consistently through various level of hierarchy. So I think for now, it was just a broader introduction about various systems and why Brown-Blanke approach can be useful, but not the only one. So it depends on scale and research goals and purposes. And now I am in the Rocky Mountains, Front Range, Colorado, and I went back 15 years ago or more when I did research in the mountains. And here you can see classification of alpine tundra communities that usually split into two big clusters. First can be called like dry alpine meadow and fellfield communities, and second one like snowbed communities. Even there are big differences between all these communities. There are like fluent gradients that sometimes make troubles when we classify vegetation. So we can see that there is a couple of fellfield and tundra communities. There is also more snowbed communities. And when I tried to summarize this into some kind of diagram, so it's complicated, but let's try it at least. I use two kinds of nomenclature or names. One are Latin names like Caricicobrezita, Loisola vaccinata, etc. And another one are like long descriptions. And this is why I prefer this kind of nomenclature that is unified, because it's more simple to talk about these plant communities with somebody. And we can see that there are certain gradients and that are dependent of elevation, snow duration, humidity. And I will speak about these names a little bit in more detail further. But I will jump into Alaska. So this is like first sketch of syntaxonomical overview, what's going on in vegetation variability in Alaska. Here we can see various data sets we collected in Arctic Vegetation Archive. There is also more data, Aaron will know, that have not been included in the Arctic Vegetation Archive, but it would be great if these different databases are linked together. And we can see this pattern, like on the left, we can see wet tundra, riparian willow shrublands, and pioneering communities. Then we have moist to dry acidic dwarf shrub communities. Then there is a cluster consisting from alpine communities from Brooks Range. And on the right side, there is dry non-acidic tundra and snowbed communities from Arctic Alaska. And when we started to repeat this pattern along south-north gradient along Dalton Highway, so we got similar results. So this pattern, even we change data set, is repeating. So we can see subalpine and subarctic herb-rich alder and willow scrub and krummholz communities that are linked with riparian habitat dominated by salix and populus species. There is also some fence base-rich wetlands and also some dwarf shrub wetland complex. Very distinctive group of plant communities are box wetlands on acidic ombrotrophic soils, but also drive to mesic dwarf shrub heathlands. And of course, again, two very distinctive communities like snowbeds and windswept grasslands were grouped together, however, with different ecological conditions. Early to late melting snowbed communities and dry mesic dwarf shrub tundra dominated, for example, by Dras integrifolia. When we can see at some ordination diagram, we can see main gradients as a moisture and temperature, higher, lower. So when switching to another diagram, now we can see variety of Arctic vegetation along Dalton Highway. We can identify zonal and intrazonal vegetation. We can see Carici cobrezieta, windswept grassland, tundra, also sometimes with dwarf shrubs. We can see acid and non-acid dwarf shrublands, and also there is very distinctive and interesting group of communities that recently been described in Arctic Siberia as Carici Hylocomieta, but this is very heterogeneous group of Arctic communities. But Helga is working on the concept of fen tundra zonal vegetation type typical for certain part of Arctic biome. And we can see also that there are communities that are drier, there are more wet, and there are also various types of azonal vegetation types. I will jump briefly into these problems. I used units that have been described in Europe. However, it's not new information, but it's coming from the 70s that Vera Komarkova already mentioned that new classes for North American Arctic vegetation should be described. And she also suggested some units that should be considered as vicariant higher syntaxa for North American vegetation system. Let's look at this a little bit closer. So here we have subalpine and subarctic herb-rich alder and willow scrub and krummholz, dominated by salix and alder species. And usually in our recent papers, we classify them as Betulocarpatice alnata viridis, that is a unit for similar vegetation types from Europe. However, there are very distinct floristic differences. Even the ecology can be similar. And there is a proposal or suggestion that maybe in meaningful system, this can be described as a new vicariant class for North American krummholz vegetation in Arctic and in alpine area or subalpine areas. We suggested this nomen provisorium, Betuloglandulose alnata crispae, as a vicariant class for subarctic and subalpine herb-rich alder and willow deciduo scrub and krummholz. Here another example, tall forb vegetation on mesic moist soils, usually classified within Mulgedio aconitetea in Europe. And on the bottom left part of my presentation, you can see Rumex alpinus communities along streams in subalpine areas, in Carpathian mountains, even in the Alps. And here are pictures from Alaska that physiognomically and ecologically are very similar. So there is new suggestion of describing new class that will incorporate all these kind of tall forb, tall herb vegetation types from North America. When choosing the name, of course, we are trying to select some taxon that is broadly distributed through most of the area. So this is just a suggestion, Senecio triangularis, but the name can be chosen any. So here are some pictures from Alaska and Colorado, how these equivalent of Mulgerio aconitate plant communities looks like in North America. And another example, snowbed communities, usually classified within Salicetea herbaceae. However, there is another syntaxon for class described from North America by Peinado in 2005, Hieracio gracilis Juncetea drummondi. Here we can see the distribution range of Juncus drummondius. So we can see that Rocky Mountains and Alaska can be covered by this new class that have different florogenesis and different geological history, but also drivers, because of similar environment, are similar as in other continents. This is just an idea how to make the system useful and broadly used. Another pictures for from snowbed vegetation from Rocky Mountains, where snow its duration and distribution is very important factor. Here we are jumping into different communities, Loiselverio vaccineatea, dry to mesic dwarf shrub heathlands. We can see them in European mountains, however, with different species. These are mainly dominated by Vaccinium scopulorum and other Vaccinium species. There is more variability of Vaccinium species in Rocky Mountains and Arctic. Here are another examples of Carice rupestris, Cobresia bellardi, fell-filled tundra, but also Cobresia grasslands. We can see different pattern. We also have scree habitats. In Europe, they are usually ordered in Thlaspietea rotundifolii, scree habitats, but maybe there is an idea, maybe also new class vicariant for these European communities should be described. It depends how many species are shared and how many species are totally different. Another example from Sangre de Cristo range in southern Colorado with few very distinctive species. And here we have typical look at tussock tundra with Eriophorum vaginatum from around Toolik Lake area in North Alaska. Here is an example of fence base ridge wetlands of Scheuitzerio palustris Caricetea fusce, again around Toolik Lake. And here are spring communities. The water is a very important driver, mainly in very dry Rocky Mountains environment. These are really important communities, and sometimes not very diverse, not very species rich, but very distinctive from other parts of vegetation that is occurring in this elevation. So we can see some pictures of Calta leptosepala primula pari. Another example of spring communities from Brooks Range, Atigum Pass in northern Alaska. And here, another vegetation type of coastal cliffs and dunes. This vegetation class can be classified as an equivalent of already classified syntaxon by Marcheno, Oncenio-Peploides Limeta arenarii. So we can see sandius covers by grasses and by species like Polemonium boreale, Armeria maritima, Androsace lehmanniana, and others. Also, we can find perennial grasslands and herbage vegetation in coastal area, salt marshes, and that's it. We can see that all equivalent that are in Europe, we can find also in the US, however, with different species composition, but with very similar environmental drivers. And at the beginning of my speech, I mentioned that amount of species or diversity in Arctic is much smaller, much lower than in alpine regions. However, there are also these very specific features called pingo from Inuit language that are ice-cored hills that are occurring only in permafrost area. They can be high 3 up to 70 meters and in diameter maybe 30 up to 1 kilometer. However, these pingos are diversity hotspots in relatively species poor environment, and they serve as macro mountains that are harboring rich ecological diversity in relatively uniform landscapes. So we can see that on very small area you can find very diverse vegetation units. For example, in upper part of south-oriented slopes of Pingo, you can find Arctic steppes, very dry vegetation. Then, for example, on northern ridges or even with different orientation, but that are on windswept ridges, you can find Dras integrifolia and Carex rupestris, more drier communities. At the top of Pingo, very common, there are zoogenetic communities dominated by Acomastylis rossi or Geum rossi with zoogenic activity. And at the bottom part of the base of Pingo, there are a couple of snowbed communities, very often dominated by Cassiope tetragona. So we can see that even small hills serves as a very diverse driver of different ecological conditions, and we can see whole bunch of different vegetation types in this area. And when we are talking about vegetation classification, and we are going through the years of collecting data, so we can do also very nice research how vegetation or environment has been changed through the years. And this is just an example that if we have classified vegetation and we have very exact maps, we have permanent plots, then we can use them for various purposes, even when using remote sensing techniques to map these changes. And we can see really big changes. You already know it. Maybe sometimes people are trying to deny it, but it's a true. Arctic is changing very rapidly, and we can see here how low centered polygons have been changed into high centered polygons. Even vegetation units have been changed through the years. So this is maybe like a warning or emphasizing that something wrong is going on and we should take care. And this is also very important to say that vegetation databases and vegetation classification is a good base for monitoring these changes. And I would like to finish my talk with what to do next. What are the next steps? Like Little John's climbing this bouldering gym in Fairbanks, while waiting for me coming back from Arctic Alaska. So we should start maybe with revising list of syntaxa for North America. And I think the easiest part is to start with Arctic alpine units. We should also validate incorrectly published names, because then we will like clean the mess that is already there, and we will create common language that will help us to communicate more clearly. And also another step is, whatever classification we use, we should have this meaningful crosswalk between various systems to be used for various purposes, scale dependent, as I mentioned before. And then we can use this data and vegetation classification for various studies, like mapping, monitoring vegetation, or for various ecological studies, solving very big and basic ecological problems, like we see from using European Vegetation Archive recently. And of course, there is big potential of using remote sensing, machine learning, and GIS techniques for analyzing vegetation and mapping, monitoring ecosystems. And of course, we can also establish a consistent ecological indicator value systems that can help us to create or monitor health and resilience of each ecosystems. So hopefully I'm on time. So thank you so much for your attention. Thank you so much that you have come to this presentation. And if you have any questions, I'm here. Thank you so much.
Yes, thank you, Jozef. You're perfectly in time. And yes, you can react. I think there are some reactions. So thank you very much. And yes, if there are questions, please raise a hand or just unmute yourself and ask, or write your question in the Q&A. I don't see yet any posts here. While people are thinking about questions, I will start. So I wanted to ask about, so in Europe we have two classes in the alpine, subalpine belts, divided by substrate, Saslariaceae and Uncetea trifidi. Did you observe some kind of analogous classes in the Rocky Mountains?
Actually, this was very strange also for me when I started do research in North America, that most communities were like, I was able to classify them within Carycirrupestris cobrezietea that are base rich but non-strictly calcareous. So calcareous mountains are not so common in most part of Rocky Mountains and in Alaska. So I was looking for something that was equivalent for Uncetea trifidi or Carycirrupestris curvulae, and haven't seen any. So most communities we can classify within Carycirrupestris cobrezietea that are neutral or base rich. However, this system is not same like in Europe. But you know, I didn't see all variability of terrain and mountain ranges in the US. So this is maybe a question for other people that are listening to this presentation, but not yet for now. I think the system like hosting most of the alpine vegetation into Carycirrupestris cobrezietea is proper. But yeah, maybe in eastern part of Canada, in Arctic, maybe in some mountains, some equivalent of Uinta trifidi can be found. But I realize that many times there are some base-rich bedrock types, and it's more complicated. Not so distinctive differences between calcareous, dolomites, and siliceous bedrock.
Okay, thank you.
Yeah.
There is one question in the chat. So from Michele, at what frequency do you collect herbarium specimens and where are they housed?
Actually, I'm trying to avoid to collect species. It depends if I have some permit or not. Once I did research in Rocky Mountains and Sierra Nevada, I got this permission, so I think they should be collected in CSU, Colorado State University herbarium. And when I am working with skip walkers, so everything is at University of Alaska Fairbanks. But usually, personally, I'm trying to avoid to collect specimens. Of course, if there is no way, so taking pictures and collecting some, but I usually leave it at University, Colorado or Alaska.
Okay, thanks. There is a raised hand by George Capello, please.
Okay. Hello, Joseph. Thank you
Hi.
so much for your excellent presentation and very inspiring too. But I have a question, for the interpretation of units at such a large scale, territorial scale, do you use any bioclimatic classification system, or in that case, which one do you refer to?
Yeah, thank you so much for your question. It's very interesting. So since Brown Blanket
problem.
approach is basically made because of floristic differences, so when trying to identify these distinctive units, I'm trying to focus on biogeography of various species and combination of these species. But when taking into account this climate or these kind of variables, so I would follow the system that László Mucina developed based on temperature and precipitation, because that system is meaningful for me. So this can be also take into account. But for example, when I am focusing on alpine communities that are occurring in Arctic and in Rocky Mountains, so firstly, I would focus on different species combination, because Rocky Mountains has different flora than in Arctic. There are some commonalities, of course, but there is many differences. So if I would go to deeper divide these newly described classes, like vicariant classes, to European units, I would go, for example, according to phytogeographical regions, and then look at climate diagrams and this kind of information. But it depends. As I mentioned, when we should take into account climate, I would follow the concept of biomes that László Mucina developed with these climograms and so on.
Okay, thank you so much, Joseph.
You're welcome.
We have another question in the chat. Fly has a question. Do you think your new approach could be applied in ecosystems other than the Arctic and alpine?
Can you repeat the beginning of the question?
Do you think your new approach could be applied in ecosystems other than the Arctic and alpine?
Yes, definitely. Even with boreal vegetation or other vegetation type, if you can go through Peinado's work, So there is more taxonomical papers focusing on salt marshes, on snowbed vegetation and others. So you can apply it. Of course, I think it needs more detailed focus and more comprehensive comparison. But I think we can apply it for a whole variety of vegetation units. So this is the idea. Since veg list list of vegetation units of Europe was revised and published recently. Oh, it's more than almost 10 years ago, 2016, by a very broad team of authors. I think something similar can be done also for North America. Maybe it will not be so comprehensive, but it's possible.
Okay, I have one more short question. I was surprised to see that you have this alpine steppes in Alaska, and I wanted to ask, what do you mean under the alpine steppe? So they share some species similar to prairies, or these are just dry communities?
Actually, these are very dry and cold communities, so when there are some grasses dominated, but definitely I should go through the species. Actually, I haven't compared this vegetation with prairies, but there can be some similarities. But definitely, for example, Calamagrostis purpurascens, dominating species, occurring even in Colorado Rocky Mountains, in Brooks Range, in alpine areas of Alaska, and also in Arctic regions. So and in Pingos. So there are some similarities, but mainly because of this very cold and dry environment. But definitely, honestly, I have to check if there are some similarities with species composition through prairies. But there are some, but I haven't done any serious comparison. So,
okay. Good. Any more questions from the audience? I don't see any. Okay. Then, now we have one. What is the most effective mechanism for creating a crosswalk between different classification approaches?
I think working with people that creating all systems. So this needs cooperation, because first we need to understand what is beyond all units that we are speaking about. So I think this cooperation is necessary, and it's a basic of anything. And then look at floristic composition and environmental conditions, and when there is overlap, so we can consider it as a crosswalk unit. So that's it. But sometimes you can have, even with people that are using, for example, Bram-Blanke approach and are doing research in the US and not doing in Europe, and maybe we are talking about same thing, but classifying them separately into different units. And when we visit different mountain ranges and discussing in the field, so we see that there are some similarities, or it's same unit. However, with different florogenesis, different geological history and everything. So, and it can be somehow classified within same unit or different unit. It depends, but that cooperation, we need to understand each other. This is the most important thing.
Okay. Then thank you very much again. It was a wonderful talk. And we will meet next time with another seminar on 25th of March. And Wolfgang Wilner and Don Faber-Langendoen will be presenting a new lecture. So everyone is most welcome. And please, if you are not yet a member of our vegetation classification working group, you can become one without any fees. And thank you for participation. and see you next time.
Thank you so much, Dennis. Thank you so much, Aaron and Scott. Bye-bye, guys.
Bye-bye. Thank you.
Thank you so much. Have a good day.